management. So there isn't really a data engineer at SME level, but it's only a mid-management and then up to senior management. I'm just would like you to kind of talk about that if possible.
Sure. Okay. Taking the latter question first, that is the data engineer. I'm not seeing that in the SME level. Data architect kind of takes care of that. Okay, just full disclosure. So data architect is someone who's going to look at all the data engineering pipelines, the infrastructure for it, the solution architecture, and so on and so forth. Okay, the data science guys, the data scientist, and at the SME level is mostly focused on the data science operational side of things. And the BI architect is the core backend guys of data warehouse modeling, operational reporting, and so on and so forth. Coming back on the entry level, first point, and reiterating again, there is no single entry point that I would like to recommend you, and even if I recommend, it would be wrong. Okay, you start from anywhere. Okay, as I said, the first 5 years, be like a sponge. If you're working as a data analyst, where essentially you work as a, let's say, report developer, you're still trying to find answers from data. Okay, let's say you're working as a data engineer, where you're building ETL jobs, you're doing data wrangling, doing different data cleansing operations, putting them in the production and seeing whether that they fit within the SLA or not. ML engineer, you're trying to figure out what is the best experimentation for a particular hypothesis that you have devised. Deep learning engineer is doing another level of experimentation on let's say image recognition. Business analyst is not technical at all, okay, but he or she is looking at how the data is being used for decision making, okay, from a very top down view, okay. But one thing that every level here has in common is that they are interacting with data at all points of time, and by nature, in a very let's say unconscious, at a very unconscious level, they are always doing the same thing again and again. Which representation of data is important for me? You talk about a BI developer, you talk about a data engineer, you talk about an ML engineer, you talk about a data engineer or a business analyst. Everybody is looking for a specific representation of data that is specific to their job. Data analyst needs to aggregate to a sum or count. Data engineer needs to make sure that there is only one record in a table for every transaction. ML engineer needs a specific representation for their features. Deep learning engineer is trying to format their images in the right format that they need. Business analyst needs their data that is looking exactly in the way which can drill down and drill up at any point of time. So end of the day, if you're interacting with data, entry level jobs, the job title does not matter. So that's my answer to your question. So there is no guarantee that if you start with a data analyst, that you are always going to be a data analyst. There's always an option at a later point of time, because you're creating a diversified exposure to the field, you can always jump from one to the other. Even another suggestion, that, and this is helpful, even if you join as a data analyst, okay, always look for options and say to your team members, let's say you have a data engineer in your team and you have joined as a data analyst, if you can help him do some of his data engineer work. Collaboration is very, very key in this field. And when you do collaboration, that is where you actually grow. Okay. So yeah, that's my suggestion for the entry level. But slowly, when you spend 3 to 5 years in this field, in that particular role that you've joined in, you'll slowly find your niche. And that's where you'll come to know automatically that, yes, I'm going to be a data scientist. I'm going to be a data architect. I'm going to be a BI architect. Not everything is for everyone, but at a baseline level, you need to get yourself exposed in the entry level to all these things. Okay, that's what my recommendation would be.
That answers my questions. Thank you so much.
Most welcome. Okay, let me move on to the next. I think we have already spent 40 minutes. Let me quickly cover a few more slides. So the hard truths. So full disclosure, the purpose of this slide is not to demotivate, but to prepare you. It's kind of what the ground reality is about this field. So there's high demand, we all know that, but there is less supply. And to positioning yourself is very, very important. And positioning yourself in the right way is equally important. Okay. Then coming to the second, the competition is fierce. So be very sure that which battles you are choosing. Okay. If you, one person said it right, that, data engineering jobs are really, really, very easy to get, or there are quite abundance in the market, and which I agree with. There is almost a 1:3 ratio of one machine learning engineer to 3 data engineer job positions in the field right now. Okay, so if you want to increase your chances, if your target is to crack a job, I would suggest data engineer would be the right option. But again, it's a decision that you're taking in your mind, that what's your objective? Is your objective to crack a job, or is your objective to work in a particular field? Okay, and that's where the bifurcation starts. The field is ever changing and very, very diverse. Okay, even irrespective of which category of jobs you're working in, consulting, in-house, or R&D, there's so much stuff coming out of this field right now. It's kind of the similar growth rate that we have seen for big data around 5 years back. There's a new library every other day. So it's kind of an ocean to get lost in. Okay. And as I said, keeping up with the latest trends can be really, really difficult. And like most of you already think that, it's, data science, data scientist is the, coolest and sexiest job of the century, but it's not that rosy as it looks from outside. It's very rigorous. The work days are really struggling. Okay, drains you out a lot, because it's not only technical implementations that we generally do in data science, but also the subjective interpretations of things, which put some pressure onto, having certain alignments of different thought process from time to time. You have to switch gears in terms of your thought process on a daily basis at every moment of time when you're doing these conversations. So these are the different hard truths, but there's also another hard truth. End of the day, it's worth it. Okay. To be very honest, this industry, specifically this domain, is one of the most entertaining and most mind simulating work that I've ever come across my peers, across my friends and family, in my personal experience as well. The kind of challenges goes across software engineering, computer science, statistical field, hardcore mathematics, and so on and so forth. And if you bring in the business aspect of things, the combinations are endless. Okay, so however difficult it might seem, end of the day, it's really worth it. Okay, every day is a new day of solving challenges or pushing for the next barrier. Okay. Coming to mythbusters. Okay, and I think this is where some of the topics we have already discussed. But to start off with, kind of a bummer statement, there is no entry-level job as data scientist. I mean, companies that are doing that, I would take a safe call here and say that that's not right. You do not become a data scientist by overnight. It's an experience that you have to gather. Okay, it goes across multiple skills. It goes across different thought process. And that is something that you can only garner across multiple years. Okay, a very quick example. So a common, let's say, so this concept of citizen data scientist that you might have heard out there in the field and so on and so forth, that everybody can be a data scientist, is somewhat true. Okay, but there is a subtle thing that you have to understand from this. So let's say you have, I think everybody here knows a little bit of how ML feature engineering and so on and so forth works. From an ETL engineer's perspective, okay, let's say you have some records in your transactional database which has some erroneous data. Okay, or let's say it has null data, not error data, but null data. Okay, so from an ETL standpoint, that data, because of the particular column being null, you can have a very straightforward rule of or logic of just removing them or put them in a reconciliation table. Okay, but the moment I change my hat, I take out my ETL engineer hat and put on my ML engineer hat, I have to be cautious. Any data set or any record that I'm taking out from my data set can be costly, because let's say I have a very small data set. Out of that, 10% of them for that particular column is null. Now the question comes for an ML engineer that do I remove the entire record or do I remove that column? So you see, the moment you shift gears, the moment you shift roles from one to the other, the next step that you're going to take changes. So these things is not something that you learn overnight. Absolutely not. Okay, and that is something that you have to keep in mind. The next thing is data science is not only about AI, machine learning, or deep learning. It is a vast field. There are many different areas of expertise in that field. Okay, talk about let's say data engineering for a while. The level of data engineering complexity that can happen, bringing into different conversations around cloud or serverless architecture or microservices based architecture or fog computing or doing. So we all know that AI uses or deep learning uses GPU, but there are libraries that can also have tremendous performance boost for your ETL data engineering capabilities as well, the moment you do that on GPU, right? So there's this huge misconception about GPU is only required if you need to have AI or deep learning. You can also tremendously increase your performance for your data engineering pipelines using GPU as well. Coming to the third, data engineering, data science is not about creating models and doing experimentation. There is a lot of software engineering involved. Okay, and when I talk about software engineering, it's about the operational side of things. So I don't know if most of you have heard about the term DevOps. Development and operations is a very disrupting idea that came up few years back. And similar to that, you have this AI ops or ML ops concept. Okay, and most of the things that go into this area is talking about how do you take a model, deploy it into production, have it in a consumable state where latencies and SLAs are more important than the model itself. Let's say, for example, you are working with a high frequency trading fund manager, okay, and you're doing this daily intraday trading mechanisms, okay, and the deep learning model that you have is, let's say, in terms of 99.7% accurate, okay, in saying that whether the next bid is going to be a successful one or a bad one. But the problem is the size of the model is, let's say, 25 GB, and it's very common to have a deep learning model of that size. Now, question comes is, how do you make sure that when your execution frequency is almost at a second or millisecond level, how do you ensure that loading a deep learning model of that volume in that instantaneous SLA? So these are the challenges in software engineering that you will find in facing the ML ops or the AI ops side of things. Okay, and hence that brings to my next point. The most difficult part of data science is the operationalization side of it. Okay, and then coming to the next, the most time-consuming part of data science is the data engineering side of things. Okay. And both of these are equally neglected by fresh graduates in the field, and that is something that I would like to influence today, if you might want to call that. Okay, you know how to model your stuff, but you don't know how to integrate that with a business application. It's not going to have much value. You do not know how to deploy that in a Flask server, create a REST API, and expose that. It's not going to be of much value. Okay. Because not everybody knows how to export your data in a pandas framework and call your scikit-learn model and get it throughout the prediction. You have to expose your consumption layer in a way that it is standard, It is widely accepted across different business applications. Final one, which we already spoke about, the ratio of machine learning DL jobs to data engineering jobs are almost 1 to 3. For every machine learning and deep learning jobs out there, you'll find 3 times the number of jobs in data engineering. Yeah, so that's the misconceptions and ground reality that we are talking about. Now coming to the skills and gaps. Before coming to the skills and gaps, any questions?
I think first of all, thank you once again for bringing that point of operationalization. I think one thing that is so important is at least to plan for operationalization. I mean, if not that you are actually going and implementing a product, but if your process is designed in a way that you are thinking about the operationalization part of your data science project, so that is something that makes a difference. So again, it's fantastic that you're bringing these points. These are, I think, less talked about in the industry today, and something very, very relevant for those who are planning to make a career in data analytics. Neil, please go ahead.
Hello, Professor. Hello, sir. My question was, so there are two ways of deploying. At least for me, I think deploying a model, either you do it, let's say, sorry, there are not two ways of deploying the model. There are two places that you can, run your deep learning model or any model. That's one is, let's say, on the client device. And I don't know if this question is relevant here, but one is the client device and one is on cloud. When do you choose either of the two? When do you want the computations to happen, let's say on the client device on a mobile phone, versus when do you want to deploy these models on the cloud so that you send a REST request, it does the model computation based on the data it gets and then pushes back the data. And maybe this question may not be. This question is, I think, related to the operations part of the. Yeah.
Absolutely fantastic question. Okay, although it's a little bit off the agenda, but let me quickly answer that. So again, so one thing, I'm really proud that you guys are asking these questions, and this is the entry point to asking the right questions to the business people when you are actually creating a product for them. And these are exactly the type of questions that you need to ask. Now, so two limitations that we see. One is where does the computation happen? Okay, and where do you serve it? Okay, now if your consumption, okay, and a key differentiator here is availability of internet. Okay, so the devices from where you are going to consume these models, do they have internet connectivity or not? If it's a smartphone like this, it's likely to have. Okay, so in that case, you can offload the entire thing to the cloud and have it REST API based. In that case, you would also need to evaluate the cost impact of running that model on your server. Okay, that's one aspect. There's another aspect of whether you would like to offload that entire model onto the edge device. That is, again, the mobile that I have in my hand. If I do that, now there are particular things that we need to keep in mind. Not every smartphone is of the same computational power, right? So you have to take a risk or optimize that what's the bare minimum model accuracy that we would like to have, because we all know the most accurate models are most heavyweight in nature as well. They have lots of different parameters. The volume goes really, really high. Asking an end device to load that kind of heavy model is almost unacceptable. Okay, so from that aspect, you have to again optimize what kind of model tuning that you would like to do, which is low in size but high in latency, and so on and so forth. So this is just to start the conversation. There are endless combinations of problems that you might come up with.
Right. Yes. Right, Professor. Right, sir. Thank you so much.
But fantastic question once again. Any other questions? Okay, moving on. Skills and gaps. Okay. Today, as you can see on the screen here, I have not mentioned Python, R, Julia, or machine learning, deep learning. That's not skills. Those are programming languages, or let's say libraries. Okay, although they are required. Okay, but let me tackle the skills gap and skills map, the 360-degree nature of it, and tell you what kind of proportion is required. Again, this is a personal opinion. Okay, this might vary. It's very difficult to generalize these things, but I'll give it a shot. So there are 5 categories of skills that are required, starting from core theoretical knowledge, spanning across, let's say, statistics, different areas of mathematics like linear algebra, multivariate calculus, and so on and so forth. Then you also have the programming skills, as I said, Python, R, Julia, different libraries, different frameworks, different tools, and so on. And then you have a very essential category, that is communication. Then comes the business acumen, and then the experience. Now, theoretical knowledge, I think you guys almost know what are the tools and technologies that we feel, but just to make sure we are on the right page, as I already mentioned, statistics, machine learning, the core concept, what's the cost function, what's gradient descent, cross-validation, hyperparameter grid search. These things should not be unknown to you or known to you only at a library level, or let's say at a package level. If someone asks you that what's the difference between a bagging model and a boosting model in ensembling, you need to at least, in very simple terms, explain what those two things are. Maybe sometimes that I've seen with candidates while I'm interviewing is that they struggle to answer the theoretical knowledge that they have. And then when I give them an example scenario to solve that problem of that same theoretical knowledge, they are able to solve it. So one key tip that I would like to give here, for corporates, when we do the hiring or when we do the interviews, when we are asking you a theoretical knowledge, you don't have to come up with a textbook 2-liner definition or something like that. Okay, and most of the guys won't even be able to understand those as well. You can always answer back with examples, and that's way more easier to explain and way more easier for the other side to understand as well. Okay, first key tip. Programming skills, again, no differentiation. There's lots of content out there, whether you go on LinkedIn or any website out there. You know, there's just 2 groups of people fighting against each other, that who is better, R or Python. Don't pay any heed to those conversations. They are all good, they are all bad. They were all, when these programming languages were written, they were written with certain challenges in mind, and so on and so forth. Next is communication is very, very important. And that is where you see communication is something that is always above average across different levels that I've shown here. Your theoretical knowledge and your programming skills in the entry level will be required a little more, and it slowly goes down when you're mid management and senior management, because they have other business operational sides to take care of, where experience, business acumen, and all those things are more important. Business acumen for entry level, it is unfair to expect anything of you, but certain common things based on common sense. Let's say, for example, how would you create a churn model? What's the false positive? What would you try to lower more, a false positive or the false negatives? So these kind of common questions, common interpretations should be possible at an entry level. And then experience, of course. Experience brings, I would say, more scenario-based knowledge rather than any other value. Okay, the more and more you work with different projects, with different challenges, you come across different problem statements, and how to solve those cases. And what it enables you is, more and more you have these kind of experiences, you look at problem solving for its problem solving sake, not as a data science problem. So this is something, some kind of food for thought for all people here. Problem solving is something you have to look at it from a very pure perspective, not only as a data science problem or let's say a supply chain problem. You don't label it. Problem solving is problem solving, and you need to look at it by its own merit. Okay, and that's what you slowly gain through experience. Okay, and here comes the most important slide for today's session. Okay, if there is anything at all you would like to take away from today's session is this slide. How do you position yourself? And I think, in my opinion, everybody says that you should look for your dream job, what you're interested in doing. Okay, but in my opinion, personally, I'm interested in doing movie reviews, to be very honest. And if someone comes and say that I'll pay you to do movie reviews, I'll be doing that job for my entire life. But I'm not that good in that. Okay, so I'm not ever going to get a job in that. Okay, so in terms of being objective towards your career goals, the question that you need to put in the forefront is, what are you good in doing? Okay, there are different aspects of data science, as I've been mentioning: analysis, engineering, machine learning, deep learning, and business analysis. For the first 3 to 5 years, expose yourself to all sorts of profiles, all sorts of roles. Understand what you're good in doing. Every single one is interested in doing machine learning and deep learning, but not all of them are good in doing that thing, right? If you're good in that, you're going to grow in that. If you're not good in that, you're not going to grow in that. As simple as that. So having said that, any questions? I know this is one place where there might be some disagreement, but yeah, let's go for it. Any questions here?
Yeah, if you don't mind, Mr. Dey.
Yeah.
Sorry, Neil, I beat you to it.
No worries,
Okay,
mate.
I am a computer science ITGS teacher. Have been for about 20 some odd years. Have been in the UAE for 15 years as a teacher of ITGS, ICT, computer science, and the likes. I have a background in computer engineering. Well, my degree is in computer engineering, and now I'm doing data science. I am loving every nanosecond of it. I didn't even know this specialty existed. What do you recommend for me? I think I am diverse. I have communicated with the KHDA more than once to try and run some whatever algorithm to try and figure out how they rate the schools, anonymously. I'm in communication with them. What would you recommend? I'm looking forward to getting out, like into other avenues. But what would you recommend for me? I mean, I do have a lot of experience in education, in teaching, and running schools and all that kind of stuff. What would you recommend? Thank you.
Okay, please excuse me if I'm being blunt on this. Okay, so my recommendation here is there is going to be a transition in your case specifically, because academics works in a very different way and the corporate works in a very, very different way. It's so you will immediately when you move to corporate, you'll see this rapid change in work style. Okay, so that's something that I'd like to highlight for you immediately. Number one. Number two is the other aspects of what you should be choosing to do. I would suggest the same thing that I would suggest any newcomer in the field. You need to first expose yourself to all the different aspects of data science, spanning across data analysis or doing the BI stuff or doing the ETL stuff, as well as the machine learning stuff, and then take a decision on that. Okay, it's just that think of it like 3 different swimming pools, but you don't know how each of them are in terms of temperature. You're only going to find out once you get into that. Okay, so that's my recommendation for you. So absorb as much as possible and then decide. Any other questions?
I did have few. I'm not sure. Abdul, did you finish yours? Okay, I think he did.
Yes, I did. Thank you, Neil.
All right. a two-part question. I think the first I'll ask right now, and then I'll give somebody else time after that. I'll ask the second one. The first one is, when you were speaking about the positions and one of the things that you were talking about is communication. Now that really caught my attention, because I think I'm not much of a communicator. I'm not very good at that. So my question here was that, so when I'm, for example, building a model, which I generally do, I come up with a few results. And when I do communicate these results with the management and, mid-management and the top management, they always ask me, but how did you come to this conclusion? Now, I can't tell them, hey, I ran nonlinear model, and then I did that, and that's how I got the results. So what is the best way to communicate results and conclusions to a top level or a mid management level person in a company? That was my first question. Like, how do I say that to them? That how did I arrive at this?
Yeah. So the key skill required here is what we call in industry is the storytelling, right? Explaining the journey of where we started and how did we reach to the destination that we are at. One key useful activity that you can take up at all steps while you're doing the implementation is to document things. Like, let's say, why did I change this hyperparameter from this combination to this one? Okay. Why did I choose the options of this output in this way and not in the other way? Okay. Then when we are learning models, okay, or when we are practicing different data science models or machine learning models and so on, one thing we often skip is the interpretation part of it. So if I ask that, what does R square mean? Okay, there's a clear functional way of explaining what R square does. Yeah. Instead of saying that here is the formula, this is what it does. No, okay, it essentially explains how much of or in very simple terms, it talks about the goodness of how well the model has fit.
The model is fitting the given test results versus the right.
So this term is much more acceptable to a business user. Okay, now they relate. So exchanging different conversations in the jargons that you use or the terminologies that you use is very, very essential, and that would essentially also, as a side benefit, will also help your understanding of the matter as well. Right. Oppenheimer, the famous physicist, once said, no, sorry, it was Feynman. Feynman once said that if you're not able to explain your
simplest terms
to a 2-year-old,
you don't
understand that well.
Yeah.
So I think while learning, because of the kind of like the structures and the way we learn things right now, we stay away from interpretation a lot. Okay, so what I do is, in our organization, what we do, we have something called sharing session, and the rule, let's say, is you cannot use any technical term in your. You have to explain random forest for 10 minutes without using, let's say, what decision tree, or let's say homogeneity, or let's say Gini index or anything. You cannot use those terms, and you have to explain what random forest model does. So I think these things are very important. These things are extremely important, I would say, because that's where those are the people who are going to lead the change to adopting advanced analytics or AI or ML in the industry, are those who can explain it to the right people, and those right people are the business people of corporates. Okay.
All right. So basically, to conclude, that is give your results by example and by concept, not by mathematics.
Yes.
Right. Thanks.
I think that's a fantastic point, Mr. Dhiman, because we used to do something similar at Majid Al Futem, where we were intentionally asked to share certain results of the complex models without using any of the mathematical terms. And there were the sessions of role plays which were done from the business and the data science team. So data science team had the responsibility of communicating everything to the business without using a single mathematical term, and then looking at what their insights are. So I think that's a fantastic way of kind of communicating the results in a more simplified manner. And I love the quote that you said that, if a 2-year-old can understand, then that's something that you're looking at. So fantastic. I'm happy to see that, it's a common practice of these kind of sessions in the firm.
Thank you. Thank you. Any other questions? I think we are almost at the last segment. Is just a little tips and tricks, search, LinkedIn profile, resumes and stuff. But yeah, if there's no question, let's jump right into it, and we'll finally go into the Q&A at the end. So, job search and application. Please do not spray and pray. I have literally seen people in front of me opening up 10 tabs from LinkedIn and just clicking quick apply, easy apply, and so on. Please don't do that. Please, I beg you not to do that. Okay, read every job description properly, understand what they're requiring. If you fit that profile, then and only then you can go ahead and apply, and take the application process very, very seriously. Respect it. Okay, sometimes you are asked to fill up a profile. You might feel that it's not required. You only fill the mandatory ones, the optional ones most people skip. It shows automatically that you have taken the time to actually go ahead and fill that application for that job. Without the expectation of someone is going to reach out to you or not, you still need to respect the application or the recruitment process. You also need to understand how to create relationships with the hiring managers and so on. Okay, and this goes out of the slide a little bit. Do not send out connection invites to every data scientist that you see in LinkedIn. Okay, or let's say every technical recruiter that you see in LinkedIn, or who's managing a team in data science, or if there is no specific. I've seen tons of people sending me a request, and the moment I accept it, the next message that comes automatically is, "Hi, my name is this. I've been doing this kind of work in this. Quick introduction. Is there any open opportunities in your team?" So I respectfully have to say them that I don't have any at this point of time. Please refer to our job section or a career page that we have on our website, and if anything comes up that is relevant to you, come back to me. Now you might think that what's wrong in this. It's a healthy conversation. Reaching out to people is fine, and so on and so forth. But understand this. It's a waste of your time. Very, very honestly. Forget about the other side. It's a waste of your time. Maybe you could have used that time to actually apply to a job which were more relevant, which were still there. Okay, instead of doing these activities. Okay, so try to optimize your job search and application process. Be very meticulous about it. Take out 15 to 20 minutes every day. Okay, search properly for those 2 jobs that you would like to apply for. 2 jobs. Okay, that you need to apply for, want to apply for, and then apply for it. Respect the process. Complete that. Okay, instead of you're having lunch on one hand, you have this LinkedIn app. Every job, data scientist job that is out there, you're just clicking on easy apply. Please don't do that. Okay. Next, on the resume and LinkedIn profile. Resume, 1 page.
Sir, sorry, I have a question.
Yes, please.
First off, thank you so much for taking the time to explain these concepts. It's been
Your
very
your
helpful.
voice is really low. Can you speak up, please?
Can you hear me now?
Yes, but it's still very low.
Okay. I said, first of all, I'd like to
Yeah.
thank you for taking your time to explain these concepts. They've been quite helpful. I wanted to ask because I am a BSc student in my final year and I'm interested in pursuing a career in data science, but I don't really have the theoretical knowledge or the programming skills because like I was just introduced to it in my business intelligence module. So I wanted to ask you like what would in starting my career in that field?
Okay. So I think based on what you have said, and because of the sound issues, uh, please correct me if I've understood this right. So you have done something around BI as part of your course, and you would like to move into this field. Uh, what should be the way that you should move forward?
Yes.
Okay. Um, so if you have got the skills specifically to a BI role, I think you'll be more you'll have more chances to land a job in that same area. Okay, like say for example, a data analyst or a data engineer for that sake as well, because you understand how to model stuff, you know how to do the data wrangling and so on and so forth. For machine learning and deep learning, you need specific skills which are most of the time specific to those areas. But while get landing the job, you can also upskill yourself. One key essential thing, I think I should have put that in the slide as well, is continuous learning in any career, not only in data science. In any career that you're in, continuous learning is very key, and that's something can make or break your career at any point of time. Okay, uh, I've seen both kinds of people. Uh, Once landing their job that they prefer, they stopped learning and they never grew. Okay, and I've seen people working in the absolute opposite profile that they actually want to work for, and slowly grew into the profile that they actually wanted to, and grew there tremendously. Okay, so continuous learning is key. Uh, it has to be a balance between the approaches that you take, whether they are tactical or strategic. So tactically, I would recommend that look for a job in data analyst or data engineer profile, which are easy to find, which are easy to crack as well. Uh, and then slowly grow yourself, groom yourself, learn more about what are the different skills and technologies that are required for the roles that you are striving for. Okay.
Okay, sir. That answered my question. Thank you.
No problem. Now, moving on to the resume bit again. So one pager, unless the recruiter comes back to you asking for more details, be honest. Please do not mention anything that you have not done or had a direct impact on. Okay, the keyword is direct. Okay, you might have helped, but it was not something that you have done on a personal level, or that was something assigned to you directly. The tone of the language in your resume should be action based. Reserve from passive statements like helped build this model, contributed to the ETL pipeline building in my team. Do not use these kind of languages. If you have done something specific, say that yes, I have built this model which gave me after this many iterations, this was the lift that I've seen in performance. This was the business impact that it has created by saving productivity by 60% or 30% and so on. Be very specific, be very quantified. Okay, we are talking about data here. As much as possible, you can quantify the outputs of your work, the better. And finally, keep it simple and clean. Okay, kindly avoid. I've seen people using fancy formats, fancy visuals, like they're 80% strong in Python and 70% strong in R and so on and so forth. Please, uh, if we need to find out you can build a bar plot, we'll give you that during the interview. Okay, But as for your resume, keep it clean, keep it simple, talk about the achievements that you have done, not something that is part of your job profile. And this is very key to understand. We sometimes think that mentioning the things that are part of your daily job, which is kind of like everybody does that, okay? Mentioning that in your resume does not add value. So think of the things that you have done exceptional from the daily tasks that you generally do, okay? And how that has helped you create an impact in the business, okay? That would help, okay? On the LinkedIn side, again, show the respect to the profile, complete that profile, every aspect of it, okay? Have an active profile. You create your profile and then you basically pray to God that someone reaches out to you. Doesn't happen. Engage with conversation, share your thoughts, see what people are talking on top of those shares that you have done. Have a healthy discussion, have a conversation, not an argument, okay? Have your colleagues, or let's say your peers or your seniors or your professors write you a recommendation, okay? Please do not misuse this concept, okay? That is also equally important. Finally, the interview preparation, okay? So there are a lot of aspects, okay, and this is entirely on an attitude level and so on and so forth. Some etiquette hygiene that I call it. Always prepare for unknowns. You will always be asked questions that are out of syllabus in very popular terms. Okay, so prepare for that and accept what you do not know. Approach and attitude is more important than the solution that you're bringing in. Okay, it's not mandatory that you have to answer to every question that you have been asked for. Okay, and that leads to my next point, which is avoid being the false positive case. Okay, one key aspect that I look for is I'm not actually interested when I'm personally interviewing a candidate. I am not actually trying to gauge what that person knows. Very honest, and this is as honest as I can get. My core objective is to find out that if he says he knows something, he knows it or not. Okay, or if he's confidently saying something wrong, and which is very risky to hire for me. Okay, someone who says that normalizing is not required at all for clustering using a K-means algorithm, and with great confidence, that's immediately a red flag for me. Okay, so if you're not sure, even a shred of doubt, you can say that, I think this would be the right thing, but I'm not sure. Or if you're not sure, you can just say that I'm not sure what the right answer is. There's no harm in that. Be honest, be transparent. That's very important. Okay. Again, another thing is have a conversation, not an argument. Okay. You might disagree, you might agree, but end of the day, we are all professionals, and have a healthy conversation. Then the other things like, be on time, be punctual, make sure that all the logistics, that your camera, your notepads, your pens, and everything are well sorted out. Be prepared properly before the interview is taking place. Engage in the conversation. Show your interest. That ask questions back. If you find trouble understanding a problem scenario that has been given to you, you can ask question. And me personally, I always encourage that. Okay, so with that, that's kind of the end of today's slides that I have. If there are any questions that anyone has, feel free to get those flowing.
Thank you, Mr. Dey. I actually have one other question. I usually bring these questions kind of up. Have you actually ever ran some algorithms of probably web scraping of some sort to ensure that this is the right the right candidate, like maybe looking at his profile of some sort. Is this the norm in recruitment nowadays, where I mean, we hear a lot, that actually managers, again, I'm talking about, I'm in the education field specifically, that, the hiring, whoever they are, they go out and they look at your profiles. Now, I'm kind of asking the same thing. Do you web scrape, or I mean, somebody under you, or have you seen it done, kind of web scrape this person to see, try to get the sentimental analysis of his personality from a data science perspective in data science?
Well, there are quite a few applications that can actually take care of these things. Okay, and we do internally in ClearPeaks have a solution that is called Intelligent Talent Finder, which does exactly the same, not exactly word scraping, but we try to do part of speech tagger and try to find out, take out information that are relevant, like experience, the companies that they work for, and so on and so forth. But in our own recruitment process, we don't have that kind of a volume to actually pass through that machine. But in other corporates where the volume of recruitment is very high, and you have low number of recruitment professionals, they generally tend to go by these softwares as well. Now, there are ways that you can actually, let's say, make sure that you are getting scrutinized in the right way. And one of those is, as I mentioned earlier, being honest and as transparent as possible in your resume is very key. And having that active and passive tone in your language in the resume is also another key indicator, which is very, very important. The systems, or even if someone manually reading a resume looks at statements like, I've helped doing this, I've contributed in this, and so on and so forth, which kind of registers in our mind as, okay, it's nice that he has done, but is it essential? That's the kind of mind space that we all go back to. Coming back to the question whether we do it or not, personally, we try to hand screen or manually screen every profiles that are coming on to us. But there are always, depending on the number of profiles that we get, there are some level of scrutinization that happen, or filtering that happens in terms of minimum criteria. Like, let's say, for example, we have said explicitly in a job description that we require minimum 3 years of experience, and the person does not have that. We have mentioned explicitly 5 years of total experience, but 3 years of relevant experience. Even if you have 10, and out of that, not a single of those years are relevant, we are going to, filter that out. So again, going back to, that spray and pray concept, we read the job description as minutely as possible. If it only fits, then only go ahead and apply, and that would increase the chances for you to get not filtered out. If the profile is, if the job description is saying that they require, it's mandatory to have a master's degree, and you don't have that, don't apply. If they say that it's a good to have, okay, it's a bonus, you can feel free to apply to it. Okay.
Thank you, sir. I do have actually another question. I mean, in my kind of like, as you have noticed, coming from the education, what would it take? I mean, I think I'm a risk taker, and most of the schools that I work with, they have a corporate and they have other businesses. So what I'm thinking about is to jump ship, kind of go up and kind of convince the people up there, the business decision makers, to say, you guys, how about we kind of have data science or analysis, or at that to that level? What would you recommend for somebody in that boat to kind of do, or in that situation as well? Thank you.
Okay, so I think again, positioning is very key here in your case, and as you have mentioned, you understand the grassroots levels of operations of how the education system works, how the day-to-day school operations work. So that knowledge, which is very close to the granular level of the education system, is available with you, and that's a great asset. And what would help you is when you go back to those management people in the business saying that, you know what, I understand how your schools work. I understand what are the challenges that you face. I have this amazing knowledge of AI and machine learning, which can enable you to solve these problems in this way. Is there any way that you are interested in? Can we do let's say an experimentation together? If it works out, let's talk more. That's how you engage the first conversation, let's say. But key thing to take away is you have to look at what strengths you have. I think this has been one of another section of conversations that I've had with senior people with, let's say, working in databases or let's say BI field for, let's say, almost 10 years. And they come back to me and saying that, Dhiman, how do I switch gears? So question is, first thing that you need to find out how much of that experience that you have, technical, communication, business, and all those other theoretical aspects and all those things that you already have is applicable to the job that you want to shift to. That is the first task that you need to do. If that gap is too high, what's the minimal shortest path to that role? So either you request or try to do an experimentation within the organization that you're in to try out different smaller projects. If they are successful, they give you experience and they give you knowledge as well. And then slowly you move to that other world. But at the same time, you have to keep in mind these transitioning are one of the most complicated challenges of career transitions, right? So you have to be very careful about it. You have to be very calculative, and you have to take calculated risks, let's say. And it's good to know that you're a risk taker. So it pans out well, I would suppose. Any other questions? I'll turn off the slides.
Yeah, I do have one more question. So, what would you expect for the freshers who just finishing up with the master? So, what would the industry would accept, require, or they would need in the resume? Like, of course, with the project wise. So, what will be the minimum requirement the fresher should come up with?
Okay, so like I said, it's a crazy market out there. Okay, and the key differentiator is to be a differentiator. You have to difference yourself from the rest. If you're not standing out from the rest, it's going to be very difficult. It's going to be very difficult to be even noticed. The number of people that graduates every year is in thousands, right? It's very challenging to make a mark. So, few tips. If you're doing a project, okay, definitely have a GitHub repository for that. Expose that in your profile. Show that you're technically competent. Do certifications. Having a degree is fine, but everybody knows that degree is something, let's say, theoretical. Okay, let's say, or I definitely know some of the degrees that are available are trying to bridge the gap, like Middlesex University here, which is very, very important and which is very, very appreciated as well. But at the same time, doing corporate certifications, like doing some Coursera courses, which are well known, well accepted, project work done in Udacity, or courses with EDX, which are very corporate oriented, would be very, very important. Now, coming back on the GitHub side of things, the project work that you have done, mention those, and please do not mention that you have done a project on the Titanic dataset. Okay, please. Okay, when I say stand out and you have to mention a project, it's not the Titanic dataset or it's not the telecom churn. Okay, everybody does that. Okay, again, and the moment we see that, honestly, it's a kind of mixed feeling. It's like, come on, not again. That's the first feeling that we get when we see, okay, I've done a project in my college, we're playing around with SVM models with Titanic dataset. Well, with Titanic dataset, if you have tried out, let's say, variations of, let's say, k-means clustering, with your custom distance function, yes, that's interesting for me. Okay. If you have done, let's say, an end-to-end pipeline of doing a survival prediction of that customer data set, you have pushed that into a, let's say, a web server, into a Flask server, and created an endpoint, and created a web page in, let's say, Dash Plotly, and called that API, got the result back, and showed the profile of that particular customer or passenger. The game changes entirely. You're not talking about Titanic data set anymore. You're saying that, you know what, I know machine learning models, but I also know how to put that into production. That's a key ingredient. Yes, Neil. You have your hands raised.
I think did you finish with him? Then I will ask.
Yeah. That's all I had. Yeah.
Right. So my question here was, Professor, Krishna Das sir said something funny. My question here is, so at one level you have GitHub, where you can have your data set and then you can make your Jupyter notebook about that and you can post it on GitHub. So I am on the side of software engineering and machine learning. So what I do is that I take models and build it for specific custom solutions, let's say chatbots, or let's say I build a facial recognition based systems. Now, those are sometimes, for example, for lack of a better word, they are sometimes bound by, let's say, confidentiality when I'm trying to build it for someone. Now, how do I showcase my stuff? I know I can't do it on GitHub. Or can I? I don't know. So how do I showcase my software engineering side as well in the machine learning space to say that, hey, listen, I'm here and I want to get into your field in machine learning, ML engineering, or deep learning engineering?
Okay. Two ways to answer this. Okay. One is, I'm being hard on you. Sorry about that.
No worries.
Beforehand. It's difficult to accept the fact that the model that you have built, let's say the face recognition app, can also be replicated with your own data. It's possible to do that. It needs a little bit of extra work, but it's possible. Okay, number one, let's get that the bad comment out of the way as soon as possible.
Right.
The next one is you mentioned that I've done this work with these people. Would like to have a conversation with them. Ask the other partner that whether they're open to be as a reference for you. Why not? Okay. And again, please don't misuse.
Okay.
If by chance they do go ahead and call that reference, make sure that they pick up and say good things about you.
Right. Okay. Or I could just, I could just take the application, duplicate the data set, and then put APK.
No. Okay. Let me correct you right there and there. Duplicating is still violating the law.
Right, exactly. So I was like, yeah, no, I shouldn't do that. Okay.
Data augmentation, if you're talking about, won't work. Still a violation.
Right. Yeah. Well, wishful thinking. All right. Thank you.
Fantastic conversation. Thank you, Dhiman.
I was going to say, if I may,
sorry,
I was going to say maybe put the data through an algorithm that will replicate it, or kind of encrypt it, decrypt it somehow, change it in some other form, and then run it through your algorithm, and then you're off of that.
And this is where I take myself back and not engaging this conversation anymore.
I'm not doing this, Abdul.
No, I'm serious. I mean, currently the other side. How much? Recently, I want to say recently. In the past 2 weeks. Just so you know, I am just to give you some background. I'm a computer engineering graduate of '95, and this year only I came back to Masters of Data Science at the Middlesex University. And like I said, I'm enjoying it. But in the past 2 weeks or 3 weeks, I have come across competitions that just made my eyes pop. And whether I win this competition or not, I want to explore them. And exactly like what you said, I'm actually looking forward for the people who are hosting the competition to just give me a certificate, say, I participated. Because some of them are just out of this world. I couldn't even believe the kind of work that is there. Like one of them is they have about 4 million images that you have to put through, to identify the images and then transform them into some chemical compound or something. So it's just actually working on it and thinking about the data engineering. Like to download the file, it took me an hour. It's like a 9 gigabyte file. And then it's not actually a data set like a normal one. It's about 3-4 subfolders inside each other of tons of images that you have to go through and analyze to get your training data and then testing data to come up with this file, which is, this is the idea and this is the chemical compound. So the idea is the process. We're trying to get there, but we're trying to get to the best of our ability. How can we, promote ourselves properly and ethically and by the book to actually get that next, jump or that next job?
Yeah, absolutely. And you had a brilliant point there, and all these competitions that are there out in the world. Let me give another pointer here. How do you make yourself stand out from the crowd? Is get a few more rings in your Kaggle profile. If you have won some competitions, that immediately gives you some credibility right there, right away. Okay. Stay away from copy pasting code from other profiles and so on, but make sure if you have won those bands, you have the goods to back it up. That's all there is. But yes, that would definitely get you over the screening process of the profiles and get you a call for an interview. But an interview is still an interview,
That's true. I think fantastic discussion, Dhiman. I think the way discussion is going on is a sentiment to how good the session was. In fact, for me, one of the highlights was, even though you were talking more about the career of data analytics and data science, it was no less than a technical session. The amount of technical words that you have used, people could relate to, the data engineering side, the model's name. So I would name it as a technical session itself. And that's a wonderfully packaged session with all the elements which are needed. And some of these tips, when it comes from someone who is in charge of leading the analytics, who is looking at recruitment, makes much more sense in terms of, these small tips that could change the orientation on what students could do, what people could do, what professionals could do. Again, a lot of our students are already working, but some of them are planning to change their career to analytics and so on. So it's a fantastic overview which they have got, and we would like to thank you so much for taking out time. And it really means a lot for people from industry to come and share all these experiences. So lovely session. And I think even the discussions were fantastic. So on behalf of Insights Lab, on behalf of the Center of Innovation and Human Experience, and Middlesex University, Dubai, we would like to thank you so much for sharing your insights. And thank you for all the students, all the professors, Dr. Fahmida, NG, who have joined in, and all the externals who have joined in for this particular session. So thank you so much. We just hope the conversation goes on. We could actually go all the way till 9 with the discussions that are going on, but maybe we'll reserve it for another session, which would be more, discussion-oriented session with you to understand more about the technical aspects, the implementation aspects of analytics. So thank you so much.
My pleasure, Dr. Nanath, and everyone in the conversation today. Hope there was some takeaway for everyone, at least some part of it. I know it's challenging at times. It's almost frustrating, but as I said, that one slide that I had, it's worth it. Okay, apart from all the dark and gloom that you see and hear, end of the day, the work is really crazily interesting, and the dynamicity in the field is it keeps me going at times when I feel that maybe I've chosen the wrong field, and at those point of time I find that there's a solution end of the day which is even more interesting. So to all of you, thank you so much for having me today. Lovely conversation. Thank you so much.
Thank you, Mr. Dhiman.
Thank you, sir. Thank you, Prof.
Thank you.